Okay, hello everyone. All right, so in this video, we are going to be following up what we learned in the last video, so the second skill from Wednesday's class, where we are taking an equation in standard form and converting to slope-intercept form. Here we're doing the opposite. I'm taking an equation in slope-intercept form and converting to standard. Okay, so given that that's the case, here we have an equation that's in slope-intercept form. We have the slope 3/8 and 1/2 the y-intercept. So really, I think this is maybe somewhat more complicated than the reverse, which you did on Wednesday, but it really only involves kind of one extra step for the most part, although the steps are different and that you're just doing some algebra. But what I want you to do is concentrate on this first, and this is a good thought here. All right, so I'm multiplying by the least common denominator, all right, both sides of the equation of the slope and the y-intercept. So what is the least common denominator between 2 and 8? I'm sure a lot of you said in your head, okay, it's 8, clearly, right? But remember, and I'm just going to go into this just as this is a short video today, if I'm dealing with least common denominator, it's really the least common multiple. Let me get my pen back here. Right. It's really the least common multiple, in that the least common multiple between two sets of numbers, that is a terrible M here. But I just want to note this. If you're having trouble figuring out least common denominator, you can just take the least common multiple between 2 and 8. So what does least common multiple mean? It means that I'm listing all the multiples of 2, 2, 4, 6, 8, 10, etc., dot, 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 and then 8, 8, 16, dot, 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 and I'm going to stop. And the least common multiple is literally the first number that appears in both lists, which I'll circle in red. Obviously, it's 8. But if you need to stop and think about least common denominator, feel free to list numbers. No one is going to judge you, certainly not me. In fact, I think I might recognize it as a sign of an excellent math student who has trouble maybe considering the least common denominator and starts listing multiples of the two denominators. That's how we find the least common denominator. So, given that that's the case, the least common denominator between 8 and 2 is 8. So if I want to multiply both sides of the equation by 8, I'm going to just indicate that here, multiply this by 8 and this side by 8. I'll bring this down so it doesn't interfere with my least common multiple calculation, which I did. But let's think about what this means when I multiply by 8. So 8y is the left-hand side, right? 8 times y. Now I'm multiplying by 8. What I'm really doing is multiplying both. This is kind of the distributive property, although my multiplier I put on the right side just for clarity. But I'll put it on the left side here just to be clear. So this is uh, 8 times 3/8 x. Wow, that's horrible handwriting. I was going to ignore the parentheses there, but that other stuff cannot be ignored. Let's try to make this a little bit more clear, though. So we have 8y. And then on my right-hand side, I have 8 times 3/8 x plus 1/2. Okay, so I'm using the distributive property in my right-hand side. My left-hand side carries down. And it's good notation. When something is not changing, when you're going step by step in the algebraic solution process, just rewrite 8y. There's no use to do equals or to do your work over the side over here. Just keep writing the equation over and over again and then write how it changes. What's 8 times 3/8? That is 3, right? These 8's cancel, or divide to 1, as it were, to make that 3x. What's 8 times 1/2? 4. Okay. If you remember, standard form is here. ax plus by is equal to c. So what I need to do, I need to make the x's and the y's on one side of the equation, right? All right, so how do I do that? You have a couple of options here for standard form. You may subtract 3x from both sides, right? Subtract 3x, subtract 3x. And this becomes negative 3x plus 8y is equal to 4. Or, alternatively, and remember, both of these sort of versions of standard form apply. I would mark either of them being correct. And that you may also, if you like, and I will, let me not write that v there. I would also accept, so this is sort of one final answer over here. I'm going to rewrite and write another one. Perfectly legit. This one here. So I'll put a line down. And then if I were to write the same, so 8y is equal to 3x plus 4. So I'm still on that same step. If you wanted to subtract 4 from both sides, subtract 4, subtract 4, so make this 8y minus 4 is equal to 3x, and then push the y over to this side, meaning that this would be minus 8y, minus 8y, and then this would add to 0. Negative 4 is equal to 3x minus 8y. And just for clarity, I'm going to rewrite this as I'll just switch the left and right hand sides. 3x minus 8y is equal to negative 4. Both of these equations would apply as final answers here, right? 3x minus 8y is equal to negative 4. So this one on the right over here. Or negative 3x plus 8y is equal to 4. Both are acceptable forms of standard form as long as the A and B terms are not both negative. So as long as one or the other can be negative, in this one, obviously, the 3x is negative, and this one, the AY is negative, then you can have a sort of a sign switch on both of these, and you can perform either way. So don't get confused. Don't say to yourself, oh, which one am I doing? As long as the x's and the y's are on one side and the constants on the other, it's in standard form. Okay, so let's do another one here. Just real quick, I'm not going to go through all the explanation listing these common denominators and the like. The least common denominator between 2 and 4 is 4. So I'm multiplying both sides by 4. When I do that, I get 4y is equal to, um, let's see, I'll just multiply it just to make this easy for clarity. I can do the reduction of 4 times 7 halves in my head, but this is really 4 over 1, right? So this becomes 28 over 2 minus 20 over 4. 28 over 2 and 20 over 4 can be reduced. So I'm going to rewrite those. This becomes 4y is equal, 28 over 2 is 14. 20 divides 4 is 5. I forgot the x up here. Sorry about that. That stays x because this is really 4 over 1 times 7 halves x. Okay, so I just want the x's and y's to be on one side. So my final and easy last step is to subtract 14x from both sides. Subtract 14x from both sides because I wanted to move the x's and y's over to the one side. So my final result, negative 14x plus 4y is equal to negative 5. Note that this subtract 5 stays as a negative 5 on the right-hand side. My final answer is here. Right. Okay. And then I want you guys to do a your turn problem just to show me that you've developed this skill. And in class on Friday, we're not going to just be working with this one skill. We're going to, like I said, or I didn't say this actually. We're going to sort of wrap up the section and do some practice with a review sheet. I'm going to give you guys a graphic organizer to sort of organize all these equations and all the skills I'm asking you to do with some steps and some hints, etc. This is something you can use for the test. So look for that as well in class on Friday. And I will see you then.